This is our final demonstration for calculating the unbiased variance for situations like in t-test where we know the population mean, but we don't know the variance, so we're estimating it from a sample. For 3C, it just says sample scores, see spreadsheet. And so we're going to have to look at the spreadsheet and see what's here and how we want to approach solving this. So here is the spreadsheet. And look at all these scores. We have a large group of people, 28 people. And to solve this all by hand would be very, very tedious. We'd have to write out, first calculate all these means by hand, and then calculate the deviations by hand, and it's just too much. And so we're just going to solve this problem in Excel. We know, however, that we have some formulas that we can deal with. We know that basically we're going to calculate the variance S squared, which is simply sum of squares divided by degrees of freedom. We already know degrees of freedom equals n minus 1. We already know that S squared itself is just the variance. If we took the square root of it, we'd have the standard deviation. We know that sum of squares is just equal to the sum of all those squared deviations. And we know that the deviations are just the difference of each individual score X minus M. So that's just a little review on what we're doing. And we can see this M right here. We know that stands for mean. And so we're going to have to start by calculating the mean. And we know that mean is just the sum of all the scores divided by n, or the number in the sample. We're not estimating anything here, so we don't need to use degrees of freedom. So let's go ahead with this larger data set and see what we can do about calculating this out. So the data go all the way down to here, but we can still calculate the sum fairly easily. So let's just tell it, the Excel, that we're going to type a formula, equals, and what we're going to get is a sum. And so we'll write the word sum, and then we'll tell Excel what we want to sum. Let's go back up to the start of what we want to sum. We know it starts in B2. We could write B2 through B29. B2, type a colon, B29. And put the parenthesis and enter and find out 2,832. Or we could just click in the cells, which is my preferred way. We could just write equals sum, put the opening parenthesis. And now we just start in one end of the range. I'm going to click here, and I'm going to keep my cursor held down. And I'm just going to go all the way up to the top of the range I wanted to sum. You can see now that all of those values have that vibrating line around it. And up in the formula bar, we have written B2 through B29. I can enter. I get the same sum. Excuse me. I know the n here is 28 because these people are numbered. So I'm going to write in 28. Degree of freedom just equals B31. I'll click in that so it writes B31 minus 1. So now to calculate our mean, I know that I need to just take that sum that I calculated before, which is in B30. I'll click in it so that B30 is written up in the formula bar. And I need to hit the dividing sign. And I'll click in the N cell. I could also just write 28, or I could write B31. Any of those would get the same answer of 101.1429. I'm glad I don't have to write all of this out. All I need to do is I'm going to write this mean way up here, and I'm going to paste it in there just as a value, not a formula. So now we have that 101.1429 written here, and I want to copy this, and I want to paste it in all of these cells. So to copy it, what I need to do, let me get off it, click somewhere else. All right, I want to just click on the cell I want to copy till the green box is around it, hit copy, which you could do with Control C, or you could do with right clicking and selecting copy from the menu, or you could do by selecting the copy icon. Now that it has that vibrating line around it, I click on the cell below it, and I'm just going to drag it to the end of the data set. My data end right here. Here's person 28. Now I'll just paste it. I'll use this paste up here. Now it's got the mean in every single one of those cells, so I can easily calculate the deviations. So let me go ahead and type the equal sign so that Excel knows I want to do a formula. And let me erase this a sec because I want to remind you that deviation is just x minus m, and that x just refers to each score. So when you see x, it refers to an individual score. So let's go ahead, equals, I want to stay in this row too. So person 1 in B2, so I'm going to click on B2 and take away the mean. Whoops, I made a mistake and typed in the minus sign, equal sign. Now we should have the correct formula. B2 minus C2, I can check it. B2 is blue up here and it's blue here. C2 and C2. It looks like I did everything correctly. So that is the deviation. Now I'm going to go click back in that cell with the formula, and I'm going to hit copy. And I'm going to paste this formula all the way down to the end of where I want to have the formula used to calculate the deviations, all the way to person 28. And I'm going to paste that in. And you could see now it's calculated the deviations for every one of these scores. The next thing is to square the deviations. So let's type in the equal sign. And let's do it just knowing what a square is. It's just any number times itself. The deviation is right here in column D. So for person 1, the deviation is 15.85714. That's how far their score differed from the mean. I'm going to click in that. It's D2 is where it's located. And I'm going to square it. And I think I'll go with the first way of doing it, which is to type the times sign and multiply it by itself. The uppercase of the letter 8 on your keyboard gives you that asterisk, which means times in Excel. And I'll say D2 again. You can write it in there or click in the cell. And now we have the squared deviation. In order to copy it, I need to click back into that cell, hit copy. And then once it has that vibrating line around it, scroll to the end of where you want it to copy, which is with person 28. Hit paste. And now we have the squared deviations. We remember here that this deviation uppercase square, this deviation caret square is just squared deviation. So the sum of the squared deviations is called SS. So we're going to sum all those squared deviations up by typing the equal sign. And again, we're telling it sum and having the opening parentheses so it knows what to sum. You can see your formula nice and neat up here. And we want it to type all of the cells from E29 back up to the top. I'm going to get Excel to fill those cell coordinates in by clicking and holding in E29 and then just dragging it all the way back up to person 1. And now that whole range has that vibrating line around it. I can hit enter. And I know the sum of squares is 14,263.43 to figure out the variance. And by this, I mean the estimated variance. So I'm going to type S caret 2. That means what the variance is for estimated. And I know that I have to, when I'm estimating, divide by degrees of freedom. So I have to type in my equal sign. And I want B34, which is the sum of squares, divided by degrees of freedom, which happens to be in B32. So I could type in 27, or I could type in B32, or I could just click in it. And then it typed in B32 for me. And here we have the variance for this particular data set. And we're not going to take it any further right now. This variance is our useful information to continue in our process. And that is the end of this demonstration.